Welcome along, physics fans. Today we're going to do a short video on Newton's first law, which is part of a series I'm planning on. Would you believe? Newton's laws! To get a solid understanding of Newton's laws, we need to just remind ourselves of two terms, velocity and acceleration. Velocity, as I'm sure you remember, is the same as speed, but with a direction. In other words, it's the number of meters per second travelled in a certain direction. So in this case, 10 meters per second in the positive direction, which is probably to the right. In physics, the word acceleration means speeding up or slowing down. Now, if you just think about that for a moment, it means basically that acceleration is when your speed changes. Or to put it another way, acceleration can be thought of as a change in velocity. Let's consider this really rather wonderful trolley that I've drawn on the board here. I normally teach this stuff with examples. So what happens to this trolley if we put onto it a force of 10 newtons? Well, some students will say it moves to the right, but that's not really good enough. I need you to think a little bit harder about it. I mean, it is going to go to the right, but the fact is that we have an unbalanced force. The resultant force on this, which is when you add up the forces to the left and the forces to the right, is clearly 10 newtons. And that means that it's going to accelerate to the right. And this is because we keep pushing and pushing and pushing with 10 newtons, so it gets faster, i.e. accelerates. In this second case, we're going to add a force going in the opposite direction. We'll keep the one to the right at 10 newtons, and we'll say that the one going backwards is 6 newtons. Most students, when I teach them, are able to tell me that the resultant force is 10 minus 6, or 4 newtons to the right. So what does that mean about the way this trolley is going to move? Well, we have an unbalanced force, therefore it's going to accelerate towards the right. But is it going to accelerate more or less than the first example, number 1, compared to number 2? Well, clearly, if the resultant force is now reduced from 10 to 4, it's going to accelerate, but not as much. This is the third case, and perhaps the hardest of the three that we need to look at. And in this case, we have the same driving force of 10 newtons going forwards, but now the resistive force is going backwards the other way, are also equal to 10 newtons. And you know that in order to get the resultant force, we have to find the difference between those two. Well, there is no difference. So that means the resultant force is 0. There is no resultant force. So what does that mean? Well, if there's no more pushing in either direction, then nothing's going to change. So one way of thinking about that is we could say the acceleration has become 0. And if the acceleration, which means change in speed or velocity, is 0, that means we now have a constant velocity. So this then is Newton's first law. It's all about the connection between resultant force and acceleration. So if you were to look in your CPG revision guide, if you have such a thing, you'd see it written something like this. If the resultant force on a stationary object is 0, the object will remain stationary. If the resultant force on a moving object is 0, it will just carry on moving at the same velocity, i.e. same speed and direction. Now that's a very nice definition. It's very all-encompassing, but it's also extremely long and wordy. There must be quicker ways of writing this. Well, how about if the resultant force on an object is 0, then its velocity remains constant? I think that's a shorter, more concise version and easier to remember.